I'd like to welcome Pen-Yuan Hsing to the, and there we go, hello. Community Council member for the, I love this name actually, I've not come across it before, but for the Gathering for Open Science Hardware. It sounds like, it's very Harry Potterish to me. And board member of the Open Science Hardware Foundation. Welcome.
Thank you. Hi everyone, good to see you. Okay, I don't have a lot of time, so I think my main goal today is to come from my experience doing a lot of scientific research to talk about how the success of open source hardware in that space might provide some useful lessons and resources that us here today can make use of, right? So I've been involved in kind of like sustainability-related research for many years now. One of the biggest projects I worked on was actually more than 13 years ago, right after the Deepwater Horizon oil spill in the Gulf of Mexico. I was among one of the first scientists to go in to assess the impact from one of the largest marine oil spills in human history. And over the past 15 years, as I have been doing my scientific research, I've gained an appreciation for the critical importance of doing open science, and I'm now a big advocate for that, and it's actually part of my current research. Staying on this term very briefly, if you ask 10 different people what open science means, you will probably get 10 different answers. So the way I like to think about it is actually the difference between science and alchemy, right? So there's this author that I really like called Cory Doctorow, and he has a quote that says, if you looked at what alchemists used to do, superficially they were doing experiments, they were taking lots of notes, they were actually learning many things. But alchemists kept what they knew a secret from each other. And because of that, they didn't advance the state of the art very much. In fact, every single alchemist had to learn in the hardest possible way that drinking mercury is a bad idea. And I think this says so much about the difference between science and alchemy, because science is a fundamentally iterative process where we're always sharing and building on what came before. So in my opinion, if you want to do good science, you will be doing open science. And to operationalize this, I always draw from the software freedom movement, right? Which talks about how for any piece of knowledge that we create, it must come with 4 fundamental freedoms for anyone to make use of it, study it, modify it, and continue to share it without restrictions. And I think these are the fundamental freedoms that underlie open source software and hardware that I'm going to be talking about today, right? So hardware underpins so much of the science that's done in the world. It is hardware that literally took us to the moon. It can be very, very large collaborations like the Large Hadron Collider, or it can be the microscopes in our labs. And of course, hardware forms the basis of all of the computational work that we've talked about so much. Unfortunately, similar to software, most of the hardware that we use today is closed source, right? And it really stifles innovation. There's vendor lock-in, right? There's no interoperability. There's forced obsolescence. Some pieces of physical hardware are physically completely fine, but then the manufacturer might remotely brick your piece of equipment to not let you use it anymore. And it is a criminal offense to open this black box and figure out how it works and fix it. And because of this, there's a lot of waste, right? And this is all part of how closed-sourced hardware and technologies have led to monopolization, which really, increases the cost for access and use of hardware. So, what's been happening is that closed-source technologies has forced us to cede a lot of our autonomy and freedoms to a few very, very powerful entities. And because of this power dynamic, it leads to a lot of global inequities from proprietary technologies, right? I have personally talked to researchers from countries, in the majority world, and the equipment that they need for their research might not even be sold where they are. And even if they can, scrounge up, money to afford it, it might not have, the service that they need, and they can't change it to adapt it to local needs. On this topic, I always like to mention Dr. Julieta Arvencio, who does a lot of research on this topic, right? And she says hardware really affects the way people think about research questions. And if the hardware is closed source, then instead of being tools that enable your creativity and addressing local needs, you are doing what the available tech lets you do, and only that. Now, in contrast to this, open source hardware enshrines those 4 freedoms that I talked about. So anyone can study, modify, distribute, make, or even sell hardware based on those designs. And it turns out that there are many successful examples of open source hardware in scientific research. One particular example I always love to talk about is the open flexure microscope. It was developed right here in the UK. I believe most of their team is based at the University of Glasgow right now. This is a very modular microscope. You can swap out the different components to give it different functions. The vast majority of the microscope can be 3D printed. And what I think is really cool is that the open flexure microscope comes with one of the best sets of documentation I have ever seen. So a researcher on the other side of the world, they would download the design files and the documentation for open flexure and be able to reproduce it almost exactly. And I think that is a remarkable achievement that's really hard to do. It comes with a lot of features, including the usual suspects, such as bright field imaging, in this case looking at a blood sample. It can also do fluorescence imaging. But what I think is cool about this particular picture is that it wasn't taken by the open flexure team. It was from a different research group that was able to reproduce the microscope and adapt it and improve it to greatly increase its resolution for fluorescence imaging. And I think this is a great demonstration of how open source technologies enable the rapid innovation where people can adapt and improve upon the technology. Now, these are just a few features from a very long list, but for you to build a lab-grade microscope like open flexure, for you to do it, the cost for you starts at just $200. Now, for those of you who have worked with microscopes in a lab before, you will know that the closed source microscopes cost thousands, if not tens of thousands of dollars at a time. But you can build the open flexure microscope for just $200. Now, because of how accessible it is and how adaptable it is, this other picture of the blood stain was actually taken by researchers in sub-Saharan African countries who have been able to build the open flexure microscope for malaria diagnosis. And because it is fully open source, it has actually created business opportunities for local businesses to form, to manufacture, and provide local services for these microscopes. And I think there's huge business potential there as well. There are many more examples. I won't go into them as deeply, but another one I love is the Open Source Imaging Initiative. This is a consortium of different researchers who have successfully built a completely open source MRI machine. And MRI machines are extremely complicated, but they were able to achieve that and get the funding that they need to do this development work. There's also open source ecology. So their group has developed the Global Village Construction Set. This is a set of 50 fundamental industrial tools, such as welders, robotic arms, or milling machines, or even a tractor, where all 50 of them are completely open source for other people to build on and adapt. There's also the Libre Solar project, which is developing core infrastructure for renewable energy, which I find to be absolutely fascinating. Open source hardware has literally gone into space. The ORSAS project is one of many that have, in this case, developed a completely open source CubeSat. And this way, other researchers, rather than having to reinvent the wheel, they can adapt the CubeSat with different sensing capabilities to fulfill their needs. Now, I think, there's a fundamental motivation to use open source technologies. There's an ethical motivation for that. But as a bonus, a lot of the examples I've talked about have spurred, successful business models. And, Professor Joshua Pierce has done a lot of work on this, right? And he's discovered that depending on your particular situation, open source technologies can provide economic savings up to 87%. compared to equivalent or lesser closed source tools. So for those of us who are already developing hardware, please publish your designs, right? Now, we know that for open source software, there are open source licenses that go with them, such as the GPL license, Apache, or MIT. There's the equivalent for hardware. The most prominent are the CERN open hardware licenses, which has 3 different varieties, from what people typically call permissive to something that's similar to copyleft in concept. So please remember to use open source hardware licenses. Communities of practice have developed best practices, such as the Open Know-how standard or the DIN Spec 3105, which allows for more machine-readable and interoperable open source hardware designs. Okay, so what are some of those communities? Well, I have been very lucky to have served in the elected leadership for the Gathering for Open Science Hardware, and we are an international network of researchers from every continent except Antarctica who are working on open source software in research. There are many other organizations. The Open Source Hardware Association is huge, and they have a lot of cool industry connections. There's the Open Science Hardware Foundation, of which I'm lucky to serve on the board of. And there's the Internet of Production Alliance, which does a lot of work on the manufacturing side of things, which is absolutely fascinating. Over the past year, we have also been very lucky to work with UNESCO to develop policy toolkits for enabling open source hardware that can be adopted on the national level, right? And there are several reports worth looking at. Again, my colleague Julieta, she has just published a report called Supporting Open Science Hardware in Academia. And just to give you an example of what's in here, right? It could be for tech transfer offices in universities, right? To show them how, rather than the traditional, really locked down approach where you patent everything, using open source software is actually another valuable and more ethical way of doing tech transfer. There's also researchers at TU Delft who have published a report on open source hardware for research and sustainable development, which is definitely worth looking at, right? And there are many other resources like this. Now, some of the people in the gathering have also developed open hardware makers, which provides mentoring and training to people who want to develop or support open source hardware in their organizations. So these are just a few examples, right? And, when people talk about open source technologies, people often think of it as, technologies along a spectrum, right? Going from completely open source on one side to something more open on the other end. And once you get closer to that end, you eventually meet the open source definition, right? So the thing is, from the little bit of experience that I have, I see that the majority of sustainable technologies or technologies for sustainability are still very much closed source and using that model. So the question is, can we move those technologies into that open source bucket, right? And I think this is so important because, again, open source technologies, are what can enable inclusive and rapid innovation that we need to address urgent global issues, right? And for example, I think, unfortunately, we are still well on our way to blowing right past the 1.5 degrees of climate change warming that we so desperately need to avoid. And because of challenges like these, we cannot afford, and we simply do not have the time to be alchemists anymore. And I think that is a huge ethical imperative for us to develop and enable fully open source technologies. So that's the message I'd like to leave with you. And I hope that some of the resources that I've pointed to could be useful for enabling the adoption of open source hardware across the sustainability sector. Thank you so much. Really appreciate being here today. Thank you to the organizers, and I hope to hear your critique and learn from all of you. Thank you.